let's take a look at, so we didn't do any effective rate? I didn't talk about $1 for 1 year? I did. Okay. That's what you do for effective rate. So for effective rate, so you're going to want to write this down because the show me an example button does a different method. Theirs is fine. You can do their thing, but it's a lot harder. They do a whole bunch of stuff. I probably said something about that, right? So effective rate, yeah. So here's my method. Put in $1 for 1 year, right? So that's the P. I should have said P there. Okay, so P, let's just do it that way. P equals $1 for T equals 1 year. So just put in $1 for 1 year. Find out what happens to $1, right? If I took $1 and said, hey, I put it in some kind of investment, and a year later it became $1.12. If my $1 became $1.12, you would know how that bank account, what the effect, right? The effective rate. You would know the effective rate of that bank account, wouldn't you? If I told you nothing else other than what happened to $1, $1 became $1.12, what would you know is the effective rate of that bank account? 12%, right? It made the dollar grow by 12%. You see what I mean? If you just find out what happens to $1, you'll know what the bank account's doing, right? That makes sense. That's my little method, which is easier than all the little formulas they have you use in the show me an example button. How would you turn this into 12% at the end? Well, you'd have to subtract back out the original dollar, and then you'd have to turn that into a percentage, wouldn't you? So that's what I'll say at the end. So put in $1 for 1 year, and then subtract out the original $1, right? Because you got to take, right? Because the dollar became $1.12, but the growth is just the 12. The original dollar was already there. That wasn't the growth. That wasn't the effect of the account, right? So you got to subtract out that original dollar, get the 0.12, which is the effect of the investment, and then change that to a percentage. Change to percent. Okay, so let's do that. Let's do that. So let's take this problem here. So they're saying, okay, 7% compounded continuously. So which we have, remember we have two formulas in this section. We have A equals P, 1 plus R over N to the NT, and A equals P E to the RT. Right, those are our two formulas in the financial section. You're going to put on the top of your 3x5 card that we're using for all the problems. When do we use this first one?
When it's annually.
No, I mean that's one of the many times, but there's other times too. When it's not continuous. Anytime it's so annually, semi-annually, monthly, daily, any of those. And anything other than continuous, we use that formula, right? We use the PERT formula when they say continuous. We good on that? Everybody clear on the different times we use those formulas? So what about this one? 7% compounded continuously. So we're going to use the PERT formula. That good? So use that PERT formula. So plug in, so take that PERT formula, plug in the $1 in the 1 year, and the rate is 7%. See if you can figure out the effect of that account. Okay, going. All right, so you guys get that one okay? So you plugged in $1. The interest rate is 0.07, and the time is 1 year. All is well. And then you just crank it out. Oh, I got my calculator. You got your calculator. So E to the power 0.07. I'm getting 1.072508. You know, I don't know. This is more than we need. Anyway, so what are we supposed to know? That's what the $1 becomes after 1 year in this bank account. Remember what we're learning. Remember, we're learning that you might think, well, what do you mean it's a 7% account? But it's really going to do a little better than 7%. Remember, the more frequently you compound, the actual effect is a little higher than the listed percentage. Do you remember what we're talking about in this section? There's listed percentages and then actual results, effects. There's laws, truth in lending laws, that they have to tell you the actual effect of a loan when you get a car loan, house loan, whatever, right? Maybe I should have reminded you of the big picture. You guys with me on that? So you have a listed percent, and then you have the actual effective percent, right? So if you have 7%, and if it's just compounded one time per year, well, then it's the same as the listed. It's just 7%, no change. 7% is, if they just compound once a year, then yeah, 7%, 7%. No difference. But if they compound more often, if they have 7% and they compounded, maybe 2 times per year, what it does is it makes it go a little higher. I don't know what it is. I'll just guess. 7.03 maybe, or that's probably too much. 7.02 maybe. It goes a little higher when they compound it. It has a higher effect. Really, your money will grow, or if it's a loan, you'll owe a little more than 7%. You'll owe or gain 7.02%, maybe. I haven't calculated it. If you 7% compounded like a whole bunch of times, like 12 times, monthly, then it'll do even better. Maybe it'll be 7.05%. That's probably dramatic. It's not quite that high. And then the highest, 7% compounded continuously. Whoops, continuously. Did I spell that right? No, I can't spell and talk. Continuously. There we go. That would be maybe 7.08 or something. I'm just guessing. So you get the idea, right? There's a difference between the listed percentage and the actual effect for interest, whether it be a loan or an investment, either way, right? And there's laws, there's truth in lending laws that say they have to tell you what the actual effect is, because that's what's going to really happen to your money, what you're going to gain or lose if it's a loan. Okay, so I'm just giving you the big picture. That's what we're doing here on these effective rate questions. We want to know, all right, they're saying 7%, but they're compounding continuously. So really, what's the effect? What's really going to happen to the money? And I'm saying, well, just find out what happens to $1, and you'll know what happens to all the dollars, right? So $1 becomes 1.07, that's a decimal point there, 1.0725, blah, 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 blah. So what do you got to do? Subtract off that $1, because that was just the original dollar you put in. So you got the 0.07, and then move the decimal 2 places to change it into a percentage. So I'm saying here, subtract the original, change to percentage, meaning move the decimal 2 places. So when I move the decimal 2 places, this becomes what? 7.2508181%. Now, how far do they want me to go? 3 places. Okay, 7.251, huh? 7.251%. That O becomes a 1 because of the 8. Remember, whenever you round, you circle the place you want to stop in. You look 1 to the right. If it's 5 or more, you go up. You know that. There it is. So the real effect of a 7% compounding continuously is 7.251. So my little table was way off. This should have been 7.251. And I don't know what the others are. I was just guessing. Good? We okay? How we doing? You guys look kind of dead out there. How we feeling? Are we alert this morning? We're halfway through the semester. Is that good news, bad news? Are all your classes with papers like due right now? They're having you do these 12-page papers are due on Monday and stuff like that? You guys look tired. Are you tired? Mm-hmm. My daughter had an English teacher here at City last semester. So in the morning he would when they felt tired, he would say, "How y'all doing? Are you feeling good? Let's stand up." And so no, they'd share their stories. They'd share their stories. So they go, "Tell us," or no. So everybody say out loud at the same time, what's on your mind, or what, I can't remember. Anyway, sorry, it's just, I'm a very different personality. I'm like, let's get to business. Anyway, but I hope you're feeling okay. I do care about how you feel at the same time. Anyway, just funny, the difference English teachers and math teachers, huh? Anyway, I'm much more different personality, I guess. All right, so let's get going. So hopefully you're feeling okay. You guys like, oh. All right, so 7% quarterly or 7 1/4 compounded. So we're going to compare rates. That's a fancy way for them to say, find the effective rate. Because that's the only way you can really compare two different setups, is you got to find the effect, the real effect of each of them. Then you'll know which one's really higher, truly higher. You know what I mean? This says 7%. Well, that looks lower than 7 1/4, but it's compounded more often. quarterly. So that'll make it go a little higher. How much higher? Will it go higher than 7 1/4? I don't think so. I think 7 1/4 is still higher, right? 7 1/4 is 7.25, right? You know 1/4 is 25 cents, right? Quarter of a dollar, quarter, right? So now I don't need to mess with this one. This one's annually. It's one time per year. It's just going to be the same, right? Remember back over here when I said if it's one time per year, it's just the same. Nothing changes. If you just compound one time a year, the listed is the effect. That's it. You're just doing it once a year. Boom. That's it. No magic change. So this one is 7.25 period. No change. It's just done annually once a year. But this one's quarterly. So let's see what the effect is. What am I going to do? Which formula am I going to use? The PERT, the first one, or the second one?
Not the PERT.
Yeah, well, I'm not being, it's this one, huh? I think we all know. It's not the PERT, huh? Because it's not continuous, right? All right, so let's put in the principal. What do you do for effective rate? P is $1, time is 1 year. Put in $1 for a year and see what happens to that dollar after a year. You'll know the effect. And the rate is 0.07. The N is, what's in? What is it?
Compound.
N's a number. What's in?
The number compounded per year.
And so what is it? It is 4, right?
4.
Quarterly, N is 4. Quarterly means 4 times a year, huh? So N is 4. 4 times 1. So then just hit the buttons on your calculator. I'm going to do that right now. 1 plus 0.07 divided by 4 to the 4th. I'm getting 1.071859. So what do? Subtract off the original dollar, move the decimal 2 places, 7.1859%. How does that compare to 7.25? This one's higher, as we thought. The 7% quarterly made it go higher, made it up to 7.18, but it didn't go past 7.25. 7.25 is still the higher on that. Does that make sense? That's how you would compare apples with apples. That's how you would know the real comparison of these loans, right? So you're looking for a house loan, right? So you ever do that? I don't know, maybe you haven't, probably not. Probably too young to buy a house yet. But, you know, they list the rates, but then how they compound it, and anyway, whatever. They list the effective right there. They have to by law. So you just look at the effective numbers. Yeah.
Okay, instead of, if it says like,
Alyssa. Yes. Go ahead. Sorry. I'm still learning. Yeah.
if it says like monthly or daily, what would it be like for monthly? Would it be 12? And
Yeah.
for daily, would it be 365?
Correct. Good. Yeah. So daily would be 365, monthly would be 12. Correct. For in. That's in.
What about leap year?
Yeah, we just skipped that. Yeah. Actually, some financial just use 360. They even round it that roughly. Yeah. Anyway, we'll use 365. All right. Good. All right. Which rate of interest is required to double an investment in 18 years? That's interesting. Okay. So compounded annually. So which of the two formulas am I going to use? Going to use not the PERT, huh? Yeah, the non-continuous, right? Because it's not continuous compounding. So we'll use this one. Good to there. Okay, let's put in what we can. Now, what do you do for doubling? What do you have? I don't think we've done this one, right? Yeah. What do we do for doubling an investment? What do you think?
Say it again.
Yeah, well, how are we going to handle the doubling? I mean, let's start plugging stuff in. What goes in for A? What goes in for P? I can put in R. R is, oh no, R's we're trying to find. Yeah, no, I can put in for R. What's in? How about that? Can I do that? Can I do anything? I'm having trouble with everything here. What's in?
1.
Yeah, because annually is once a year. So in is 1, exactly. We good with that? Time, what's time?
U2.
Now there's T, 18 years. Good. So I'm getting close. I'm down to A and P. I just wrote down the formula and I'm plugging in stuff. A lot of times,
Now let's say
math, science, I just start that way. Just write down the formula, plug in what you can. So now I need A and P. What are they going to be?
doubling in interest.
Yeah,
Like 2 times.
doubling is 2 times, huh? Doubling is 2 times. So what should I do?
2p?
Is it 2p? What is A?
Yeah.
P is 2p and p, like that?
No.
No?
Yeah? We should just
Yeah, that's exactly it. Yeah, because what does it mean if you double? The amount is twice whatever the principal was, huh? It's 2p. See, I don't know what p is. I don't know what the principal investment was, but I know the amount is going to become twice the principal, right? That's what it means to double. The amount later is 2p, is twice the principal. Is that good? Is that making sense? We good on that? Now, let me pause here. This is one of these, I've seen a mistake that hurts a lot of people over a lot of years, done a lot of times. So I'd like to do whatever I can to help that not happen for you when we take this test in a couple weeks. A lot of times people remember this mostly, but they make one little mistake. I've seen this mistake a lot in the tests I've graded. They'll put a 2 there instead of a 2p. Now, why is that such a problem? Well, then they're stuck because you see they can't divide off the p. Whereas if you have the p there, first step is just to divide off the p, and it's gone, and then we just have 2 equals, 1 plus the r to the 18th, and away we go. We can get the rest. But but the mistake people make is they'll just put a 2 there, not a p. I've seen that a lot as I've graded tests over the years. They'll just put a 2 there, and then they're like, I'm stuck. I don't know what to do with that p. I got a p, I got an r, I got 2 letters. How am I going to handle this? And then they can't finish. So watch out. Remember, that's 2p, not just 2, right? Make sense on that? Right? Let me say one more word that might help. What if I said to you guys? What if I said, just to help show how it doesn't make sense to just put a 2? What if I said, hey, double? What if I just said that all by itself? Double. You would think, double what? Wouldn't you? Because double alone is meaningless. It's got to be double, something, right? So that's the whole point. Double alone is meaningless. It's got to be double something, doesn't it? Just maybe that helps. It's got to be double P or double something, so it's double P, right? That's what it means. So it's the double the principal. Now, having said that, it's totally fine if you want to just put like a 1 here and a 2 there. That'll work too. Basically, you can either put the P in both places or put it in neither, because it's going to divide out anyway. So that's okay too if you want to just put nothing or 1 here and then 2 out there. That'll work, either way. Formally, it's supposed to be P and 2P because there is a principal. We just don't know what it is, and the amount's double. And then it's just going to divide out first step anyway. So it's gone. So we're to here now. We good to there? Okay, now, how am I going to solve that for R? That's a weird looking equation, isn't it? That's pretty strange looking. Any ideas? How are we going to solve that for R? We're trying to solve for R, right? What rate? That was our question from the beginning. What rate?
Move stuff over.
Yeah, like what? Move what over? What would be my next step?
Power over.
What do I do? Yeah, how so? Just like put it on the 2? So I mean, like I got to do something to both sides, right? Whenever you have an equation, it's a system in balance. Left side equals right side. They're equal. Treat them the same. They'll be equal afterwards, right? So what am I going to do to both sides? And then somehow it'll help me. I mean, I got to get that R alone, right? The name of the game is R saying, I want to be alone. Get rid of this 18, get rid of this 1 so that I can be alone, right? That's what we're trying to do. So how do I get rid of that 1 and get rid of that 18?
So the 1 side by 18?
Do what's that?
Square root side by 18?
Square root side by 18?
118?
Exactly. Exactly what we need to do. Yeah, because think about how would you get rid of a, what if you had 1 plus R squared? What would you do? Square root, huh? 2 root. So how do you get rid of an 18th power? 18 root. But another way to say that might be easier for you is a 1/18th power. That's the same thing. You can write 18th root if you want to. It's the same as a 1/18th power. Remember, roots are the same as fractional powers. Remember that connection? So either way will work. I think this might stick better in your mind, but if you like the root thing, do that. That's the same thing as just going 18th root of 1 plus R to the 18th. Either way, it'll cancel it out. There are 2 ways to say and do the same thing. Does that make sense? Right? So if you have a 2 power, you square root. If you have a 3 power, you cube root. If you have an 18th power, you 18th root. Don't you? That gets rid of the 18th, or 1/18th power, same thing. And whatever you do to one side, you have no choice but to do the same thing to the other, huh? Got to keep the balance, right? Now hold on. Let me address a good question. Because a lot of times when I would ask my math teachers, I would see what they did, but I would think, well, why can't you also do this? And it's important to get those questions answered. Why? I heard somebody say it, and it's good thought. Why can't we just do natural log? I thought this was the time for natural log. Why didn't I mean, this is going to work, and I'll finish it in a minute. But why didn't I do natural log of both sides? Isn't that what we do with the power thing? Why didn't I do natural log? I hope you know. I'm not sure you do, but I'm glad I'm addressing it to give you that information. It's important to more clearly understand when you do natural log. This is not the time. So when is the time? I did the whole Hitler and Stalin stories. I'm hoping it really sticks well with you, but I know there's a small detail you're probably missing. When? When do you do natural log? Not quite here, almost here, not quite. What's different? Because you need to know it. In a minute we're going to have to do it. And you got to be crystal clear when and when not.
Because you had to keep the R in its own?
The letter has to climb into the power.
Good, Mando. The letter has to be in power. Not just that it has powers, but the letter's in power, right? That's why I did the big thing about Hitler, right? Doesn't matter, if the wrong guy gets into power, that's the problem. I'm trying to put that concept in your mind. So when the letter gets, if R was up there, yeah, I would totally do LN. That's right. Dethrone that power, right? Get it out of power, right? And we'll have that in a minute. We'll have T up there. And then I will do LN. But here I just have a number. I just have a number up there. That's not the end of the world. That's not such a terrible thing that you have to actually do LN. So is everybody getting that idea? It's a big deal when the letter climbs into power, right? When Hitler or Stalin climb into power, right? That's the big deal. Something needs to be done. All right. So 2 to the 1/18. I'm just going to leave it. In a minute, I'll hit the buttons on the calculator, but it's going to be some ugly decimal. I'm just going to leave it a little cleaner right now. These guys cancel. 1 plus R. Now it's cake, huh? Just subtract 1. So it's 2 to the 1/18 minus 1. Y'all have your calculators? Let's hit. I hope you bring your calculators with you because some of these things aren't the easiest. I want to make sure you can do them. So I can help right here or right after class if you have any trouble. So 2 to the 1/18. I'm getting, 0.039259226. Y'all getting that in your calculator? And then, we got to turn it into a percentage, so move it 2 places. So it's 3.9. How many places they want it? Oh, 2 places. 3.925, so that rounds to 3.93, doesn't it? Percentage. There we go. 3.93% is the interest rate that'll make money double in 18 years. Compounded annually. Is that good? Questions on that? That okay? You ever heard of the rule of 72? Investment people always talk about the rule of 72. Any 2 numbers that multiply to be 72 will double money if one of them is the percentage and the other is the rate. Roughly, approximately. For example, right here we see that. Take 9 times 8. That's 72, right? That means if you have a 9% account for 8 years, your money will double. Or if you have a 9 years of an 8% account, your money will approximately double. Or if you have any other 2 numbers that multiply to be 72, in our case, it's 4 and 18. This is basically 4, 3.93. It's basically 4, 18. 4 times 18 is 72. That means at a 4% account for 18 years, your money will basically double. That's the rule of 72. Investment people know that. Gauss came up with it years and years ago. So anyway, you don't need to. You don't need that. But you know, if you know that rule, then you look at 18 years, you go, the answer is about 4. I know the answer is about 4 because 4 times 18 is 72. And sure enough, the answer came out to be about 4%. Okay, let's try that one. So same kind of thing. Crank that one out. So it's compounded annually, so I'm going to use the A as P1 plus R over N to the NT. Triple means 3P. Annually means N is 1, huh? Once a year. Annually. The interest rate is what we're trying to find. The time is 26 years. What's that?
Same thing.
Same thing. Is that good? Good to there? You guys cranking it out okay? So then, yeah, divide off that P right away. Boom, boom. So 3 is 1 plus R over 1 is just R to the 26. So, yeah, same thing. So everybody good to there? So just raise both sides to the 1/26 power, or the 26th root, same thing, you know, whichever way. Because it's just a number in the power. It's not a letter. That's not Hitler up there. That's just some other president we don't like or something, right? It's not that dramatic, right? People feel dramatic about the United States presidents, but they're not Hitler or Stalin, right? The ones I like and the ones I don't like. All right, so that cancels out. So 1 plus R, 3 to the 1/26. Good? All good to there? Then just subtract that 1. So 3 to the 1/26 minus 1 is R, and then hit the buttons on the calculator.
0.0.
And we get, 0.043, 159, 1597, blah, 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 blah. Move it 2 places. 4.3, how many do they want? 2 places? 4.32, yeah, it rounds to 3.2. 4.32%? Is that okay? How many got that? Did you get that? A few of you getting that? Maybe half? Questions I can answer? Or maybe you could have got it if you had your calculator with you or something. Is that good? All is well? All right. I always feel like I'm begging you guys for questions. Let's just do the second part. How about? Continuously. So they're saying how long for it to double compounded continuously. Hey, what's the guess? Look at that. 8%. What's your guess? Now we can use the rule of 72. Gauss's rule of 72. It's approximate. Right? 8%, that's for money to double. That doesn't work for triple. We couldn't have done it on the triple problem we just had. But for doubling your money, 8%, you just say 8 times what is 72? 9. The answer's got to be close to 9. Because, right, any two numbers that multiply to be 72, they're doubling numbers. If one of them is the years and the other is the percentage. They're approximately how long it takes money to double. That's what investment people throw around. So as soon as we go 8%, about 9 years. The answer should be close. Oh no, this is a hard one. Oh no, we need to do this whole thing. I didn't read the fine print. They're asking for something different. They're not asking for the rate.
They're asking for the year.
They're asking for the years. That's going to be harder. Yeah, we got to definitely do this. Yeah, let's go back and do the first part. We'll do both parts. Yeah, I was going to skip it. I gotta be a little more careful. Yeah, let's do the first part. Let's do the 8% monthly. We're guessing the answer is about 9 years because 8 times 9, 72 for doubling. Anyway, so we're thinking we should get an answer about 9. That's might be helpful to you on the test just to know. That might be enough just to grab the right multiple choice answer right there. I don't know. Okay, so let's give it a go. So for monthly, that's N is 12, and I'm going to use the P 1 plus R over N to the NT. Okay. All right, so let's put in stuff. What the amount is double the principal, and the interest rate is 8%. The N is 12 monthly, and the time is what we're trying to figure out. How long? Good to there so far? What's the first step? Divide off that P, right? Like always. Then we get 2 equals 1 plus 0.08 over 12 to the 12t, like that. Good so far? Bring it up here. So 2 equals 1 plus 0.08 over 12 to the 12t. Okay, so what should we do to solve this one? T is saying, I want to be alone, right? The letter's always saying, I want to be alone. Get me alone. I got all this other stuff. I want to be alone. Get rid of all this stuff so that I can be alone. So how do we do that? What are we going to do?
Dethrone.
LN. So this is what I'm talking about. Everybody see the difference why this one's LN instead of like some kind of 112 power or something like that? It's not. Because it's the letter in power, right? So let me write that. So letter in power, LN, both sides. Everybody catching that? So it's the letter that's climbed into power. So that's different, whereas the last one just was numbers, wasn't it? Back here, see, this was just a number in the power zone. The letter was already on the ground level, was on the base level, huh? But when the letter's in power, that's a serious issue. That's more difficult, right? We can't handle that easily. We need the special tool of LN. That's that great third property. Remember the log properties? Remember the third property that says powers can come down to the front? That's the great quality of logs. So that power comes down to the front. So we get ln2 is 12t ln of 1 plus 0.08 over 12, like that. And once you get that letter out of the power zone, you dethrone it, you get it down to the base level, then it's really pretty easy. You know, that's so much easier at that point once it's out of power. So now that it's out of power, this is just 12 times t and t times it's just all multiplied, huh? So we just divide all that stuff, just one fell swoop. Just divide by the 12 and the ln of stuff, and it's just all gone. And whatever you do to one side, you know you have no choice but to do the same thing to the other. Is that good? So I divided both sides by 12 ln of 1 plus 0.08 over 12. And t is alone. See how the big deal is getting t out of power, getting it down to the ground level. Then it's just divide. So then hit the buttons on your calculator. We got a big old mess here. All of that. Can you do that? I want to make sure you can. Remember now, see how we have two things in the denominator? We have a 12 and an ln thing. So that means what when you type it into your calculator? When you have two things in a denominator, you have to put parentheses around it. I see that mistake a lot. I hope you're okay with that. Put parentheses around it as you type it into your calculator. So let's do that. ln2. Oops. I'm getting, remember we thought the answer would be about 9, right? 8.693 years. And they said round to two places, so it's 8.69. So yeah, just under 9 years. We thought the answer would be about 9. So just under 9 years. There we go. Is that good? Questions I can answer on that? So see the difference between these last two and the letters in power, LN. That goes for many other situations. Whenever letters in power, LN. Good. Move on from these. Questions I can answer? If you have any trouble with your calculator, I'd be glad to help. Just come up afterwards. And 10 seconds, I can help you with your calculator. They're all a little different, so do that individually. All right. Okay, let's do the continuous. So what are we going to do for the continuous? I'll do it quick. It's the same thing. It's just the other formula, huh? Which is actually, I think, a little easier. The PERT formula, because it's continuous. So the second part is they want you to do the same thing with the other formula, the PERT formula. And then the amount, again, is 2p. Same thing, because double. And the rate is 8%. And we're trying to find the time. It's a little easier, isn't it? Not quite so messy. And then just divide both sides by the p like usual. Boom, boom. Bring it over here so we get 2 equals e to the 0.08t. Am I going too quick? So I'm just doing part B, or the second part of this question. So you just divide off that p on both sides, like that. And then t's in power, so you know the deal. ln both sides. The whole power is dethroned. Takes Hitler out of power. And the ln of e is 1. Like that. So 0.08t is ln 2. At this point, it's just divide. Once the t's out of power, it's so easy to handle it. Just divide by 0.08. And there we go, ln 2 over 0.08. I'm getting 8.66. 8.66. You want two places. 664, so I'm just going to leave it at that. 8. So very close to the other answer. What was the other answer? 8.69, very close. 8.66 years. This one's a little lower because continuous compounding is a little more effective. So you need a little less time to double your money. Not much, though. It's pretty close. Is that okay? Questions on that? Good? Move on. This one. Okay, so what interest rate compounded semi-annually will yield an effective interest rate of 6%? Let me give you a second. Rather than me just dive in, I think you'll get more out of it if you try it first and maybe get it, maybe not, but either way you'll get more out of it. Yeah.
With the dollar?
Yeah, good question, huh?
I think
Yeah.
that's what-
So how about this? You know, a lot of times I'd read physics, especially physics was the hardest thing I took at junior college. And I'd read a physics question and I would just go, I have no idea. They're like, physics was like all word problems. Anyway, so I'd read them and I wouldn't know, but there's always one place you can start, right? The formula. So I learned that if I just stared at it, nothing good ever happened. But if I wrote down the formula and just started moving, you know, that a lot of times I'd go, oh, something would happen. A lot of times it wouldn't. But more chance there than not. So what formula? Let's start there. What formula am I supposed to use?
The non-continuous.
The non-continuous. So let's just put that thing down and at least look at that. Now we're going somewhere, you know. All right. So looking at that, let's just go letter by letter. Let's start with the A. Can I put in the A? Do I know the A? Is there any way that I know the A? A is the amount later, right? Everybody clear on what maybe that'll help. The amount later, whereas the P is the principal invested at the start, right? We good on the meaning of those letters? So the A is the amount it grows to later. The P is the amount principal put in first at the start. So you put in a principal now, it grows to be an amount later. So, any thoughts? What about the A? Do I know the A? What are we supposed to do for effective rate problems? What did I always say? Let P be $1, let time be 1 year. Right? Put in $1 for 1 year. That's how you handle effective rate. Just find the effect on $1 after 1 year. So anyway, do I know the amount? Do I? What is it?
The interest with the 0.06, right?
Okay, so what's the amount? 0.06?
1 point.
1.06?
Yeah.
Exactly. Very good. Everybody see that? What if I told you, hey, I've got this account, and the effect was 6%. What's going to happen to my $1? Remember, P is supposed to be 1. What's going to happen to my $1? If the effect, which means the final result of some account, ends up being 6%, well, my dollar will become $1.06. Exactly right.
Really?
Does that make sense? Mm-hmm. That's the effect on a dollar of growing by 6%, isn't it? Is that good? So we do know that. But when somebody says, here's the effect, well, then you know what happens to your money, right? In the end. That means the final result. So the $1 becomes $1.06. That makes sense? And then, do I know the R? No, that's what they're asking for, huh? What interest rate? So they're saying, what's the listed percentage? It's going to be lower than 6%. It's going to be 5 point something. You guys getting the idea? There's going to be a listed percentage that's lower than 6, like 5 point whatever, and it's going to grow. It's going to have the actual effect of 6% because it's compounded semi-annually, more than once a year. How often is semi-annually? 2 times a year. So N is 2. And what's T? 1 year, right? P is always 1, T is always 1 for effective rate problems. It's always $1 1 year. So I'm going to solve that for R. Does everybody see that? Everybody get the big idea of the question? They're saying what interest rate will have an effect of 6%? What interest rate done twice a year, semi-annually, will have an effect of 6%? So it's going to be something under 6, right? It's going to be 5.89 or something like that. And it's going to actually have an effect that's 6%. Remember, the effect is higher than the listed if it's more than once a year compounded, right? Remember this chart I gave you? Somewhere. It's a long time ago. There. Remember? The effects are, unless it's once a year, then the effect is the same as the listed. But the effects are always higher, aren't they? The effects are always higher than the listed when it's compounded more often. And the more it's compounded, the higher the effect is. If it's compounded only 2 times, it's just a little higher. 12 times, it's more. Continuously, it's quite a bit more. Right? Remember that? You get that big idea of listed and effect? So with that in mind, when they tell me effect is 6%, I'm thinking a listed must be below that. So what's the listed rate twice a year that'll have an effect, make $1 into $1.06? That's the effect. Okay, solve that equation for R. R is saying I want to be alone. So let me bring it over here. So I've got 1.06 is 1 times 1 plus R over 2 to the 2. So what are you going to do to that thing?
So you drop the one time.
Do I do natural log? Yeah, you can get rid of the 1. 1 times anything is just itself, so let's just get rid of that 1. I agree. That 1's not important. The 1 added matters, though, right? Adding 1 matters, but multiplying by 1 doesn't change anything. All right, anyway, R saying I want to be alone. Should I L in? Should I L in both sides? No, because letter's not in power. It's not that serious. It's not Hitler or Stalin in power. It's just a president we're not thrilled with. But it's not a letter in power, right? It's not. So it's not L in. It's not that serious. It's just square root both sides, basically, huh? Or half power. Same thing either way, right? You know it's the same thing either way. So it's just a half power both sides, like that. That good? Like that. So, or you could square root. Same thing. So that gets rid of that. Finish solving for R, subtract 1 from both sides. 1.06 to the half power minus 1, R over 2, like that. And how do you finish getting R alone? Multiply by 2. That good? The whole side by 2. Boom, R's alone. So hit that on your calculator. Let's do that. I'd probably start with the inside. Yeah, well, you can do whatever. It doesn't matter. I'd probably use 0.5. I'm getting 0.059126, and then move the decimal 2 places. 5.9. What did they say? 2 in the final. 5.91%. Yep. See how we expect it to be a little bit below 6. 5.91% listed has an effect of 6% done twice a year. How we doing? Is that good? Questions I can answer? You okay with all these financial problems? I'll move on. No questions? Okay, so $1,000 invested semi-annually. How long till 1,300? So semi-annually, that's N equals 2, and that means I'm going to use the A as P. It's not continuous, the non-continuous formula, right? And here we go. What's the amount? Do I know the amount? The amount I want it to become later? That's the 1,300, isn't it? Right? We want 1,000 to grow and become 1,300. So the amount later is the 1,300. The principal now is the 1,000, isn't it? Good so far? Want 1,000 to grow and become 1,300. And then the interest rate, 5%. N is 2, as we said. Time is what we're looking for. Maybe I better do one or two more steps. Is that good? Everybody see how I came up with that? It's starting to make more and more sense, I'm hoping. Okay, so how do we, T is up there saying I want to be alone. So that's Hitler Stalin, that's serious. The letter's in power, right? The letter has climbed. So we're going to do LN, but we're not quite ready to do LN right now. Yeah, that's what I wanted to help with. So when the letter's in power, so let me write one more step because there's one more step needed here. When the letter's in power, number one, get base alone, and then LN both sides. Huh? You know what I mean by get base alone? Like what am I?
Base isn't alone.
Yeah, what am I going to do first on this one to get the base alone?
You're gonna have to get rid of that 1,000.
Exactly. Is everybody good with that? Good. You first got to get rid of that 1,000 before you do the LN thing. You want the base to power thing alone before you do the LN. So that'll be 1.3 is 1 plus 0.05 over 2 to the 2t. Now we'll LN both sides. Now, on the next line, I'll go ahead and LN. So once you get the base to power structure alone, then you LN both sides. Then this power slides down to the front. We have LN 1.3 is 2t. LN 1 plus 0.05 to the 2. We've dethroned the power. Hitler's out of power. Stalin's out of power. And then we can finish solving for t. Just divide by 2. LN 1 plus 0.05 to both sides 2. LN 1 plus 0.05 over 2. 2's cancel. The LN's cancel. T's alone. Hit the buttons on your calculator. Whatever you get, you get. I'm going to move on. Is that okay on that one? Questions I can answer? They all have a little bit different wrinkle, don't they? Good? All right. All right, so survey estimates that the current average cost of college, $32,309 per year. Wow. All right, if the average cost of college increases 5.7% per year, what will be the average cost of college in 12 years? You've probably heard all the stats, right? That college goes up every year faster than inflation. It has for the last decade at least, right? So college costs are outpacing inflation by like double. I mean, they're just crazy. You can go, there's a million articles, you know.
But they keep doing things for like our college is pretty much like 60-70% free for most people. So
That's correct.
Giving other incentives to kind of
Right.
that.
So there's some other incentives. You're totally right. Yeah. All right. So let's run the numbers. So this one is so it's a growing cost thing. That's basically these formulas we've been using. When things grow over year, inflation or growing costs of any kind, that's these formulas we've been using. So is this one continuous or not? Oh no, so it because it says right here, yeah, let me help with that. 5.7% each year, that means n equals 1. Does that make sense? When they say something grows by 5.7% each year, they're saying every year, once a year, 5.7% growth. Next year, 5.7% growth. Next year, 5.7% growth, right? That's like once per year compounding, isn't it? That's the exact same, that's exactly what it is when they say something like that. So this is the same formula you would use if they said inflation is, whatever it is, 2.3% per year. How much is this computer going to cost in 10 years? Take the cost now, and then you just do the same formulas we've been using, and every year means n equals 1, one time per year with that percentage. Okay, so I'm using the A equals P, 1 plus R over N to the NT. Not the PERT, because it's not continuous. It's once per year, right? Okay, so what's the A? That's what I want to find out, huh? What's the amount of college going to cost? What's a year of college going to cost in 12 years? What's the principal? That's the 32, right? So the principal is the starting now, and the amount is what it'll be in 12 years. It's like we're investing the 32,000 and seeing what it'll grow to be in 12 years. That's exactly what we're doing, right? We're saying college costs 32,000 now. What's it going to grow to be in 12 years? So the 32,309, that's the principal. The rate is the 0.057, right? Got to change that to a decimal. The N is once a year, and the time is 12 years. We good with that? So there it is. Let's just hit the buttons on the calculator, but I want to show you all the plugins. So 32,309 times, let's see.
So I just basically turn to a number problem.
I'm getting an amount that is $62,838, and it rounds to 15 cents.
Wow.
Oh yeah, that's right here, huh? Yeah, I got that answer. So there it is. Look at that. What do you think of those numbers? College in 12 years. As a dad, those numbers pain me. I've got a kid at Cal Poly I just dropped off a month ago. And that I'm getting a cheap deal compared to that. Anyway, yeah, college is going up, up, up. Up,
There's
up,
other
up, up.
effects
What's that?
to it. There's other effects to it.
What did you say? The other effects?
There's other effects with it. So
Other-
even if inflation goes up, I mean, it's going at a higher rate, which is
Yeah.
not good,
Right? Yeah.
but your dollar is also going with it. Your pay rate, the minimum average to pay for different household items and stuff like that.
Well, those are not going up as fast. That's
Minimum wage
Yeah.
and other things, but yeah, just that's the difference. That gap is still increasing.
yeah, that gap is growing. Yep. So there we go. And now the second part, savings plan. Oh yeah, and then let's do the second part. So if a savings plan offers a rate of 4.4% compounded continuously, how much should be put in the plan now to pay for 1 year of college 12 years from now? So, okay, so what are they talking about? Let me show you that second part and we'll be done with this section. Okay, so now over here, so this was part A, and now for part B. So part B says savings plan 4.4% compounded continuously. So in part B, we're talking about continuous compounding. So I'm going to use the PERT formula, right? For part B. And they're saying, okay, what are they saying exactly? They're saying, how much should you put in the bank now to pay for 1 year of college in 12 years? So what if I'm looking at those numbers as a dad and I'm saying, oh man, I got a kid going to hit college in 12 years. How much do I need to put in the bank today? And it'll grow at 4.4% compounded continuously, so that 12 years from now, it'll hit that number. And I could go, here you go, honey. 1 year of college, it's all you get. Study hard that year. Take 47 units and hope it all works out. So, all right, so that's what they're asking. So how much in the bank now that'll grow in 12 years to become that 62,000 number, right? Right, that'll pay for 1 year of college in 12 years, which is what we just figured out right there. 1 year of college in 12 years. So that's the amount we want it to become. You agree with that? That makes sense? And the principal is what they're asking for. What principal in the bank today that'll become that in 12 years. And the interest rate is 0.044. And the T is 12 years. I'm kind of running out of room here. Times 12. Right? Maybe I can squeeze these in a little bit better. Yeah. Good. Can you see all that? So there we go. We're trying to solve that for P, the principal. So to solve that for P, the principal, it's just divide. Principal is already on the ground level, so that's not bad. Just divide both sides by e to the 0.044 times 12. P equals, I don't know. Oh, yeah, it must be this number right here. 37,060 90. So if you just put $37,000 in the bank today, you got an extra 37,000 laying around, right? Let's put 37,000 in the bank today. Let it grow for 12 years at 4%. It'll become the amount of money needed, and your child can go to college for 1 year. So there we go. Is that good? Questions on that? All's well? I move on. All right, so I'm going to stop here. I'm going to say, everybody catching this? Everybody dialing in? If I've been doing the Charlie Brown teacher voice, dialing right here. You'll like this announcement. 5.7 homework. Skip number 24, 25, and 26. Right? That's where, because this is 23, right? Wasn't this 23? Yeah, 23. So this is 23. So skip the last three. They're messed up. They're not good questions. So skip them. So don't worry about it. I mean, I can't alter. I would just alter it if I could. The program EthicSale doesn't let me change the assignment after people have worked on it because it would mess up grades. So it won't let me just cut them out. So don't worry about them. Just let them be. It'll say you're only got 90% or whatever, but your grade will be fine. I'll fix it in the end of the semester. It'll all be good. So just skip those three. And we're done with this section.